So what we did just now with the radicals and reducing the radicals is really Algebra 1 stuff. Okay, it's stuff that is it should have been a review from stuff you've already done. And so today we're going to expand on that idea, and we're going to kind of introduce the Algebra 2 portion of it. Okay? So we talked before, and this is just going to be in terms of, I'm going to make this a little bit bigger. We're only going to get through the multiplying today. We're not going to get through the dividing. But if you look, what are these little numbers that I'm getting ready to highlight? These guys out here. Do you remember what we called those things? Indexes. They are in variable form right now, but they are the indexes. If there's not a number there, we assume it to be a 2. If there is like a 3 or a 4, for example, these indexes have 3. Can you have a 3 and then go to a 4? Can you change your index ever? The index should never change. So this is going to be a false situation, okay? Over here, huh? No, I don't want you to write any of it down right now. I'll tell you what to write down in a minute, okay? Right now we're just looking at what could be true versus what's not true. If I have the same index, I multiply them and I keep the same index. So if I look here and here, they all have the same index. So that's good news. What does this rule or this property tell me to do? It tells me to multiply what's underneath the radical. Is that what they did here? Is 9 times 4, 36? Yes. So this is a true statement. Okay? How about over here? Are all the indexes the same? Okay, so that's a good start. Is 3 times 8, 24? Yes. So we know that we have a good start here. This is the example that I'd like you to write down. Okay, so if we would, we're going to simplify, and these are the things you kind of already did. Okay, if you look at, actually, well, don't even write this one down yet. I'll show you the one that I want you to write down. Just watch for now. We're going to circle the indexes. We have 4 and 5. Are they the same or are they different? They're different. Can I simplify them if they're different? No. Okay? So, can't do it. How about over here on the right? 4 and 5 aren't the same number. It's hard to see in the back, probably. Over here on the right, Travis, I agree. 5 and 5, these indexes, they are the same. So that means that I can simplify it. The product would be, the 5 stays there, and I multiply what's underneath. What's negative 5 times negative 2? 10. So the fifth root of 10 would be how I'd simplify that. Okay? This is one I want you to write down. Okay? I'll write it big. I'll write down what you need to write down. The cube root of 128 times x to the 7th. This looks very familiar to what you were working on, except for the index is 3 this time. So I'm going to be looking for groups of 3. Okay? So let's deal with the number first, then I'll deal with the variable part. So let's reduce the cube root of 128. What are some factors of 128? 8 and 16. Double check him. Do you agree? Okay. Any 2 would work, by the way. There's a whole bunch, any 2 2 and, we're going to have to go down on both of them. Very good. We have to continue to simplify. Okay, so 2 and 4. Uh-oh, this one's not, hang on, this one's what? 2 and 8. I know, we're going to keep going. Well, 16 is 4 and 4, so you could, but then this would also be, I know what you're going to say. You can take a larger one out first. Huh? 8 is a perfect cube. You're right. Is that what you were saying? Yeah. And so 2 radical 16 is yes. There's some of you who can do that part in your head. Awesome. Not everybody's there yet. So if you don't mind, I'm going to continue. Okay? So 2 is a prime number. 2 and 2. 2 is a prime. Keep bringing that down. Because if you don't bring down your primes, you're going to lose them. As I was walking around earlier, a lot of us were losing some of our prime numbers, so just continue to bring them down. And then we have 4 and 2, and then we have 2 and 2 again. So hang on. So we have this 2, this 2, this 2, this 2, 2, 2, and then another 2. I'm looking for groups of 3. How many groups of 3 did I have? So I'm going to bring 2 times 2 outside of my radical. So remember we have cube root, right? So what comes out? 4. What stays under? 2. So I've just dealt with the numbers right now. That's all I've done. Okay? A little bit bigger of a factor tree. We don't want to lose anything. Now let's deal with the numbers part. So again, I have a 4 on the outside, and I have a 2 on the inside. Let's deal with the letters, the X's. And that's it? Good. Now, since there are 7 X's, there's a shortcut that we know, or we can write all 7 of them out in circle groups of 3. Because we have one group of 2 and another group of 2. 2 times 2 is 4. Remember, when you bring them both out, you get to multiply them. I'm going to write down 7 X's. I'm looking for groups of 3. I have one group of 3 and another group of 3. So x squared comes out. Exactly. I have 1 left over, and it stays underneath the radical. Okay? The numbers just get bigger, and the groups just get bigger. We just have to look at our index to know how many groups we're bringing out. I don't see any cubed anything. The 3 is the index. That just helps me remember to look for groups of 3. Okay? All right. This one's the harder one. Okay? I'm going to write it a little bigger because I think it's a little... Yes, dear. I want you to multiply them, though. You need to multiply the numbers out in front if you bring them both out. All right. So I'm just going to write a little bigger here, okay, so we can see in the back. What is my index in this case? 2. So I'm looking for groups of 2. There are 2 ways to solve this problem. I can reduce them both first and then multiply, or I can multiply in the beginning and reduce my answer. I personally think that's the easier way of the 2. Multiply them together and then reduce. Remember, I can multiply anything as long as the indexes are the same. Okay? Are my indexes both 2? Yes. So I can multiply. What is 45 times 35? Try again. What's 45 times 35? 57? No. Oh, I'm sorry. I thought you said 57. I couldn't hear you. 45 times 35 is 1,575. Okay? Now, I have to write, I have x to a power and I have y to a power. What is the power of x? When I multiply x to the 5th times x, what do I do with the exponents? I add them. So it'd be x to the 6th. And then what would the y power be? Y to the 7th. Very good. So I'm just multiplying. At this point, I need to reduce. Let's deal with reducing the square root of 1,575 first. So I'm going to make a little factor tree. Don't I already have 2 numbers that work? 45 and 35? So I'm going to start there. And I know they both keep going. I know they both keep going. 5 goes into both of them, I agree. So 5 times what is 45? 9. And then 5 times 7. Well, the 5, but 9 reduces. Do I have any pairs? Because I'm looking for pairs this time. Well, because it started with 45 times 35, I knew I started there. Okay, I just used what was given to me. So what are my pairs? Let's circle a pair of 3s. And the 5s are not written next to each other, but aren't they a pair also? And then what's left is the 7. So I'm going to bring out a 5 and I'm going to bring out a 3. What number is that? Am I totally bringing out? 15. And the 7 stays underneath. So I have 15. I'm going to leave some room for my variables. And then I have a 7. Any questions so far? So I'm looking for my variables now. Good question, yes, sir. I knew it was 2 because the index is a 2. If there was a 3 as the index, I'd look for groups of 3. And the one we did prior to it had groups of 3 because the little number was a 3. If it's not there, it's assumed to be a 2. Okay? All right, so now we're going to look at our variables. We're going to look at x. I'm going to write 6 of them. If this is the long way. If you are smart like Raul, you know right away that 6 divided by 2 is 3, so I know x to the 3rd comes out. I have groups of 2. I have 1 left over, right? So I have x to the 3rd, y to the 3rd, and I know I have an extra y left over. There's your answer. So when you are multiplying these radicals, and you're going to have some for homework in addition to the worksheet, okay, you multiply what's underneath the radical first, and then you simplify that answer. Pay attention to your indexes, okay? So your homework is just going to be on multiplying. If you did not finish the worksheet, you need to do that first. About half of you did finish. And then you also need to do on page 371. I will. You're going to do 10 through 36 every other even. What do I mean by every other even? 10, skip 12. 14, skip 16. 18, I'm trying to save, I could say I just do the evens, but I'm trying to save you some time, okay? All right, so this is a homework. I'm trying, okay?